Welcome back to the Deep Dive. Today, we are not just busting a myth. We are really dismantling a massive cultural institution.
Oh, absolutely. It is the heavy hitter of neurological folklore.
Right.
It is the zombie statistic that just will not die no matter how much science we throw at it.
I am talking, of course, about the idea that human beings only use 10% of our brains. You know the drill. You have seen the movies.
The sci-fi blockbusters.
Exactly. You have seen Limitless with Bradley Cooper, or you have seen Scarlett Johansson and Lucy.
Right, where she unlocks the other 90% and turns into a literal USB drive at the end.
Yeah.
Spoiler alert for a 10-year-old movie, by the way.
Fair enough. But the premise is always the exact same. You, the listener, are just a normal person stumbling through life and utilizing this tiny cranked fraction of your gray matter. But, and here's the hook. If you could just pop that special clear pill or get exposed to some mysterious sci-fi radiation, you would unlock that dormant 90%.
And suddenly you are learning piano in an hour. You are predicting the stock market or mastering languages while you sleep. And in some of the more extreme versions, you are literally manipulating matter with your mind.
Ultimate power fantasy.
It really is.
It is the ultimate what if. It tells us that we are all secret superheroes who just have not found the light switch yet. But today we have a very specific mission. We aren't here to just say, oh, that is wrong and move on.
No, that would be boring.
Exactly. We are going to look at a massive stack of research today. We have neurology papers and historical archives and studies on savant syndrome and even ethical papers on genetic engineering.
Just a light read.
Yeah, just a bit.
Yeah.
But we want to find out why this lie exists and what the truth actually looks like.
And I think it is really important to say right up front that we aren't doing this just to be buzzkills.
Definitely not.
We aren't trying to disappoint anyone who is sitting there hoping for superpowers.
Because what we found in the research, specifically looking at the biological reality, is that the truth of how the brain actually works is infinitely more fascinating than the Hollywood version.
The Hollywood version is actually kind of small when you think about it.
It really is. It relies on magic. But the reality relies on engineering.
It changes how we view learning and how we view intelligence. And frankly, it changes where the future of human potential actually lies. It is not about unlocking magic. It is about efficiency.
So let us look at the stack we were working with today. We've got articles debunking the myth from Common and clinical neurology specialists.
Excellent sources.
We have deep historical and neurological context from the Avalon Library and Unlocking the Mind. We also have some really heavy academic research on savant syndrome and something called the neural efficiency hypothesis.
And we are going to cap it all off with some fascinating and honestly slightly terrifying ethical papers on genetic enhancement and embryo selection. If we cannot unlock the brain, we have the next logical question is, can we build a better one?
So buckle up. We are going from the 19th century all the way to the near future. But I feel like we have to start with the obvious question. Where on earth did this 10% number come from?
It is oddly specific.
It is. It is not just some of our brain or half. It is specifically 10%.
Like most persistent myths, it is basically a game of historical telephone.
Right.
It starts with a grain of truth, a very philosophical grain of truth, actually, and then it gets distorted by marketing until it becomes a hard statistic.
Let us trace the call then. Who started it?
We have to look back to the early 20th century, specifically to William James.
Okay.
Now, if you aren't familiar, William James is often considered the father of American psychology, a towering figure in the field. And in 1907, he wrote a famous essay called The Energies of Men.
The Energies of Men sounds very dramatic.
It was very of its time. And in that essay, he made a very philosophical observation. He wasn't holding a scalpel or doing brain surgery. He was observing human behavior.
Right.
And he said that most people only make use of a small part of their possible mental and physical resources.
Hold on. That sounds fundamentally different from the myth we were talking about.
He is talking about potential. He is talking about focus and discipline and effort.
Yes.
He is saying you could work harder. He is not talking about biology at all.
Precisely. He was speaking entirely metaphorically. He meant that we get tired or we get distracted and we settle for mediocrity.
Right.
He never mentioned a percentage. And he certainly never mentioned unused biological brain tissue. He was basically acting as a high-performance coach saying, you guys are leaving a lot on the table.
So how do we get from a philosophical do your best to 90% of your brain is biologically offline? That is a massive
Massive leap.
Enter the marketing spin.
Wow.
Fast forward to 1936, Dale Carnegie publishes How to Win Friends and Influence People,
A massive bestseller.
one of the most influential self-help books ever written.
I think everyone has a copy on their shelf somewhere, or at least their parents do.
Exactly. Now, in the foreword to that book, a journalist named Lowell Thomas wanted to make a punchy point to sell the concept of the book. He summarized William James and his idea, but he tweaked it.
Yeah.
He wrote that Professor James used to say the average man develops only 10% of his latent mental ability.
And there it is, the number.
That is the exact moment the metaphor calcified into a statistic.
Wow.
It sounded scientific. It had a hard number attached to it. It cited a very famous psychologist. And it was in a book that millions upon millions of people read.
It just became self-help gospel overnight.
It really did.
It is amazing how sticky that kind of thing is. It gives it this veneer of credibility. It actually reminds me of the Einstein quote.
Oh, yeah.
You always see this myth attributed to Einstein, right?
Yeah.
That he said he was a genius because he used more of his brain than everyone else.
That is another classic piece of folklore. We actually checked the archives from Common Note and a few others on this. There is absolutely no record of Einstein ever saying that.
Not all.
Zero. It is what historians call intellectual appropriation.
Right.
If you want a myth to sound true, you just slap Albert Einstein's name on it. It gives it this unassailable authority.
So we have a misquote from a psychologist and a completely fake quote from a physicist.
Yeah.
But let me play devil's advocate here for a second. Was there actual science back then that confused people? Because early neurology was pretty primitive, right?
Huh?
Did they see something that actually looked like 90% inactivity?
That is a really fair question, and it is a huge part of why the myth survived. In the 1920s and 30s, you had early neuroscientists like Carl Lashley mapping the brain.
Okay.
And this was really the Wild West of neuroscience. They would take a rat, or sometimes even a human patient during surgery, and stimulate parts of the cerebral cortex with electricity just to see what happened.
Literally just poking it to see what jump.
Basically, yes. And the results they got were very binary. In the motor cortex, if you zapped it, a muscle would twitch, a finger would move.
Right.
In the sensory cortex, the patient might report feeling a tingle. But in the large areas of the brain, massive swaths of the cortex, actually nothing happened. No twitch, no tingle, no sound.
And they called those the silent areas.
Right. They coined the term silent cortex. And the misunderstanding was logical, but dead wrong. They assumed silent meant inactive or useless.
But we know now those areas aren't doing nothing.
Far from it. Those silent areas are actually the association cortices. They are responsible for the highest levels of integration in the brain.
Meaning what exactly?
They are taking the visual data and the memory data and the emotional data and stitching them all together. They handle language and abstract thought and planning.
The big stuff?
Exactly. Connecting point A to point B, they are the very things that make us human. They just do not make your finger twitch when you zap them with a battery.
It is like looking at a computer and pressing the M key and seeing a letter appear on the screen and assuming the keyboard is the only part of the computer that works.
That is a perfect analogy.
But then you look at the processor and you poke it with your finger and nothing moves, so you just assume the processor is garbage.
Exactly. You are mistaking the input mechanism for the processing power. But even with the bad science explained, we have to ask a deeper psychological question. Why do we want to believe this so badly? Why is this myth so resistant to dying?
I think the Common Note article hit the nail on the head here. It is about hope, and it is about agency.
It really is. It offers a very convenient biological excuse.
Right. If I am not achieving what I want in life, or if I am struggling to learn French, it's not because I lack the skill or the discipline. It is just that my brain switch is flipped off.
And if I could just find that switch.
Then I would be a god.
Yeah.
It is an incredibly seductive promise. It basically means greatness is easy. It is just locked away. It completely removes the burden of hard work.
And where there is insecurity and hope, there is profit.
Oh, for sure.
The sources point out that entire industries are built on this. Brain training apps and smart supplements and nootropics, they are entirely built on this modern anxiety that we are somehow under-optimized.
They're selling you the key to a door that literally does not exist. So we have looked at the lie. Let us look at the truth. And we need to get technical here for a minute.
Okay.
Why is it physically and biologically impossible for 90% of our brain to be doing nothing?
The first argument against it is pure economics, evolutionary economics. You have to understand that the brain is an incredibly expensive organ to run.
Okay.
It represents about 2% of your total body weight. It is just about 3 pounds of jelly, essentially.
But it consumes way more than 2% of our energy, right?
Massive amounts more. It consumes 20% of your body's entire energy intake.
Wow.
It runs on about 20 watts of power. Now, 20 watts sounds low. It is roughly a dim light bulb. But in biological terms, that is a massive tax on the body.
Because evolution is a ruthless optimizer.
Exactly. If you have an organ that is eating 20% of your food but only doing 10% of the work,
You would be extinct.
you would be entirely extinct. Evolution works strictly on efficiency. If 90% of the brain were useless, humans with smaller and more efficient brains would have survived easily.
And the big-brained humans would have starved to death because they needed too many calories.
Precisely. Evolution would have selected for smaller brains millions of years ago. Nature simply does not let you carry around a backpack full of rocks that you never ever use. It is metabolically greedy.
And we can actually see this activity now, right?
Yeah.
We do not have to guess like Lashley did with his little electrodes.
Yeah, we have fMRI, which is functional magnetic resonance imaging, and we have PET scans now. And what they show is totally decisive.
What do they show?
Even when you are doing something incredibly simple, something like just clenching your fist, activity does not just happen in the one little fist area of the motor cortex. It flares up across the entire network.
The sources used an orchestra analogy that I really liked for this. Can you break that down?
Yeah, think of the brain like a massive symphony orchestra. When the violin has a solo, it is the most prominent thing you hear.
Right.
That is the focal task. So maybe you are focusing on a math problem, but the rest of the orchestra is not dead just because the violin is playing.
The percussion is keeping time.
The cellos are monitoring the harmony, the conductor is watching the tempo.
So the rest of the brain is actively maintaining the system.
Exactly. It is monitoring sensory input from the room. It is maintaining your physical balance in your chair. It is regulating your heartbeat and breathing. Even when one area is the soloist, the rest of the brain is actively supporting.
And even when we are sleeping, because that is when I assume the 10% myth might actually feel true to people. Like, I am asleep, so my brain is off.
Especially when we are sleeping, the brain has what we call the default mode network,
Okay.
and it is furiously active during rest. It is consolidating memories and moving data from your short-term to your long-term storage.
Like saving files to a hard drive.
Very much so. It is also literally cleaning out metabolic waste products that build up in the tissue during the day. The brain is never actually off until you are dead.
There's also a cellular argument here too, isn't there? Use it or lose it principle. This part of the research actually kind of freaked me out a bit.
It should freak you out. This is really the final nail in the coffin for the myth. Neurons are not like computer chips that can sit on a shelf in a box for 10 years and then be plugged in and work perfectly.
Right.
Neurons are living biological tissue. If a neuron is not used, if it does not fire and connect with other surrounding neurons, it dies.
It physically dies.
It undergoes a process called synaptic pruning or apoptosis. The body basically says this isn't being used and it is a waste of energy, and it actively reclaims the materials.
So if we really did not use 90% of our brain.
Your brain would physically wither away. It would look like a shriveled, diseased raisin.
Oh, man.
We see this in autopsies of people with severe neurodegenerative diseases. A healthy brain is incredibly dense and packed. A brain with 90% inactivity would be totally unrecognizable.
And we see the inverse of this with brain damage too. I mean, if 90% was really useless, you could theoretically take a bullet to the head in those silent areas and be totally fine.
Exactly. You can remove huge chunks of it and not notice. But clinical neurology shows us that damage to even tiny microscopic areas causes devastating deficit.
Right. You lose the ability to speak.
Or to recognize faces of your loved ones, or to move just your left index finger. There is no safe place to damage the brain because there is no unused real estate in there.
So the 10% myth is totally dead. We can officially bury it. We use all of it.
All of it.
But, and here is where the conversation pivots and gets really interesting. There are people who seem to defy the normal limits of what a fully used brain can do.
Yes.
We have to talk about savant syndrome.
Yeah.
Because if I am using 100% of my brain and they're using 100% of their brain, how are they doing that?
This is where we shift from thinking about the quantity of brain to the wiring of the brain.
Okay.
Savant syndrome is incredibly rare, and it usually involves a specific triad of conditions. It is blindness and musical genius and a mental handicap.
The famous example that everyone knows is Kim Peek, right?
Yeah.
The real-life inspiration for the movie Rain Man.
Yes. Kim Peek was absolutely fascinating. He wasn't autistic, actually, which is a common misconception, but he had severe brain anomalies. He was born entirely without a corpus callosum.
Define that for us. What does that do?
The corpus callosum is the thick bridge of nerve fibers that connects the left and right hemispheres of your brain. It is basically the information superhighway that lets the two sides talk to each other and coordinate.
And Ken just did not have that at all.
Did not have it.
And his abilities as a result were just alien.
He could read 2 pages of a physical book at once. One eye read the left page and the other eye read the right page, independently and simultaneously.
That is just hard to even picture.
And he remembered 98% of everything he ever read in his entire life.
Yeah.
He memorized roughly 12,000 books. He was quite literally a living Google before Google even existed.
But this goes right back to my question. If I use all of my brain and Kim Peek uses all of his brain, how is he doing that? Did he just have more raw brain power?
No. And this is the crucial insight from the research. He did not have more power. He had reallocated power. It is a profound trade-off. Kim Peek had this massive deep memory, but he struggled intensely with basic motor skills. He could not button his own shirt.
Right.
He also struggled heavily with abstract concepts. He could not really understand metaphors or jokes.
So it's a zero-sum game. You pull the blanket up to cover your head, and your feet get cold.
To an extent, yes. The PMC source discusses a really fascinating theory called paradoxical functional facilitation.
That is a mouthful.
It is a total mouthful, but the concept itself is brilliant. The theory is that usually the left hemisphere of the brain, which handles logic and language and dominance, acts like a bit of a bully.
A bully.
Yes, it actively inhibits the right hemisphere to keep us focused on the big picture of survival.
So the left brain is basically saying, do not look at every single tiny detail and do not memorize every single license plate we walk past. Just tell me what the object is so we can move on with our day.
Exactly. It filters out the noise so you can function. But in many savants, there is severe damage or dysfunction in that left hemisphere, often from prenatal testosterone toxicity.
So that inhibition is just lifted entirely.
The tyranny of the left brain is gone. Suddenly, the right brain is totally free to process raw, unedited detail, perfect pitch or exact structural measurements or photographic memory, and it processes all of it without being filtered or stopped.
But that implies something crazy. It implies that the capacity for these wild skills is actually in everyone. It is just being suppressed by our own healthy brains.
That is the dormant potential argument, and it actually has some serious scientific weight behind it.
Really?
Yes, there are documented cases of acquired savant syndrome.
Acquired, like you catch it.
Like you get hit in the head. Normal neurotypical people who get a severe head injury or sometimes develop frontotemporal dementia, and suddenly out of nowhere they can paint absolute masterpieces or play the piano flawlessly.
That is wild.
Yeah.
So the circuitry to do that was there the whole time.
It absolutely seems so. But again, it comes at a terrible cost. They usually lose their social skills or language ability as the trade-off. It is not a fun superpower you just get for free. It is a radical reallocation of biological resources.
There is also this myth about savants that I saw debunked in the reading, that they aren't actually creative rights, that they are just human tape recorders spitting data back out.
That was definitely the old way of thinking, that they could only replicate exactly what they heard or saw. But the modern research shows a clear progression.
Walk me through that.
Take the case of Leslie Lemke. He was blind and severely developmentally disabled. He heard Tchaikovsky's Piano Concerto No. 1 exactly once. He heard it on a late-night TV movie, and he immediately sat down at a piano and played it perfectly.
Unbelievable. But that is the replication phase, right?
Just perfect copying. But over time, he did not just play it back. He started adding his own flourishes to it. Then he started fully improvising new sections. And eventually, he started composing completely original music. The progression goes replication, then improvisation, then creation.
It shows that even with a completely rewired brain, the fundamental human drive to create is still there.
Exactly. It is fundamental to the architecture.
So if savants show us one extreme way of wiring, what about high intelligence in just regular neurotypical people? Does a genius brain light up more than an average brain? If I take a Nobel Prize-winning physicist and put them in an fMRI, is their brain just glowing like a Christmas tree compared to mine?
You would naturally think so, right? You would think a really smart brain is working much harder and firing on all cylinders. But the neural efficiency hypothesis says the exact opposite is true.
Wait, so smarter brains actually do less work?
In a way, yes. The imaging research shows that when a highly intelligent person solves a moderately difficult cognitive task, their brain actually shows less cortical activation than a person of average intelligence doing the exact same task.
They're just way more efficient.
Think of the car analogy we used earlier. If you have a highly tuned, high-performance sports car and a beat-up, old, heavy sedan, and you ask them both to drive down the highway at 60 miles per hour.
The sedan is shaking violently. The engine is revving super high. It is working incredibly hard just to maintain the speed. It is loud.
Right. And the sports car?
The sports car is just cruising along in fourth gear, barely breaking a sweat.
Exactly. A smart brain effectively filters out the noise. It knows exactly which highly specific neurons to fire, and maybe more importantly, it knows which ones not to fire.
It inhibits the irrelevant information.
Intelligence isn't about raw, explosive power. It is about the signal-to-noise ratio.
This connects directly back to that seizure argument from earlier.
Yeah.
If you actually fired 100% of your neurons at the exact same time, that is not genius. That is a medical emergency.
Right, that is a grand mal seizure. More is absolutely not better in neurology. Targeted is better.
So can we upgrade this hardware? We always hear people talking about neuroplasticity. Can we actively build a better brain?
We can adapt it, but again, you have to remember the zero-sum game. The famous London taxi driver study is the perfect example of this.
I love this study.
It is a classic. These drivers in London have to memorize something called the knowledge. It is 25,000 twisting streets in London.
And all the landmarks.
Right. It takes literally years of intense daily study to pass the test.
And their brains physically change from doing that.
Yes. The posterior hippocampus, which is the specific area responsible for spatial navigation, got physically demonstrably larger, measurably bigger on a scan.
So that is the upgrade right there. Proof of neuroplasticity.
It is proof, but there is a catch. Their anterior hippocampus actually got smaller.
And what does that part do?
That is the area responsible for forming new visual memories. So they became these incredible super navigators, but they actually got slightly worse at certain types of complex memory tasks compared to the general population.
Wow. So you push on one part of the balloon and another part bulges out, or in this case, shrinks.
Exactly. It seems we have a relatively finite amount of neural real estate. We can definitely renovate the house, we can knock down walls and move things around, but we cannot easily add a massive new wing without tearing something else down to pay for it.
Let us actually talk about the specific specs of that house. We have some hard numbers in the sources about the true memory capacity of the human brain. Because we often feel like we are full, right?
Oh yeah, all the time.
Like I will be studying or working and I just think, I cannot learn another single thing today. My brain is totally full.
That feeling is very real, but it is attention fatigue. It is not a storage capacity issue. The actual hardware specs of the human brain are staggering when you break them down.
Lay the numbers on me. I want to feel technologically impressive.
Okay, let us look at the cortex. The cerebral cortex alone has roughly 125 trillion synapses.
Trillion with a T.
Yes. Those are the microscopic connections between the individual neurons.
125 trillion. That is just hard to even visualize in your head.
And researchers estimate each one of those synapses can store about 4.7 bits of information.
Okay.
So when you do the math on that, the total estimated storage capacity of a normal human brain is roughly 2.5 petabytes.
2.5 petabytes. I am trying to wrap my head around that scale. How does that compare to the technology we use every day?
Think of it this way. A terabyte is 1,000 gigabytes. A petabyte is 1,000 terabytes. So we are talking about 2.5 million gigabytes of storage in your skull.
So compared to my smartphone, which is maybe 256 gigabytes?
Your phone is an absolute toy. It is a rounding error. But here is a much better historical comparison. Think about the computer on Apollo 11.
Okay, the one that went to the moon.
The exact one that guided humans through space and calculated the orbital trajectory and safely landed the Eagle on the moon. That computer had exactly 64 kilobytes of memory.
64 kilobytes. That is nothing. That is like a blank Word document.
It is incredibly small. And to give you a more modern and massive comparison, The clinical neurology specialist source compared the human brain to Yahoo's massive data warehouse.
Yahoo?
Yes. This is a massive physical facility that tracks the online behavior of roughly 500 million users. It is one of the biggest single databases on planet Earth.
And how big is that?
Yahoo's entire global data warehouse is about 2.0 petabytes. Your brain is 2.5.
Are you kidding? So I have more raw storage capacity sitting in my head right now than Yahoo's entire physical data center.
You absolutely do. The problem isn't storage. We do not have a hard drive problem at all. We have a retrieval problem. We have an attention problem.
The distracted librarian.
Exactly. The library itself is basically infinite, but the librarian is easily distracted by a bird outside, or they sometimes lose the index cards, or they just flat out refuse to go down into the dark basement to find the older files.
That is actually a really comforting thought.
Yeah.
It is not that I am stupid or my brain is small. It is just that my internal librarian is currently on a coffee break.
Essentially, yes. The data is all in there somewhere.
Okay, so we have this massive, almost incomprehensible capacity, but we are heavily limited by biology, by energy consumption, and by those necessary trade-offs. We use 100%, but we are constrained by the physical limits of the machine itself.
Right.
But what if we could actually change the underlying biology? This brings us to the really wild part of the research, the future.
This is the true frontier of neuroscience and ethics right now. We are slowly moving away from training the brain, which is very slow and has hard biological limits, to engineering the brain.
The sources talk heavily about genetic cognitive enhancement, or GCE.
Right. And there is a very crucial distinction we need to make here between embryo selection and gene editing. We need to completely separate these two concepts to understand the ethics.
Okay, break that down for us. What is the difference?
Embryo selection is something we already do to some extent right now with IVF or in vitro fertilization. You create several embryos in a lab setting and you screen them.
Right, usually for health reasons.
Exactly. Usually right now we screen them for severe genetic diseases like cystic fibrosis or Down syndrome. But the science is rapidly moving towards screening for something called polygenic scores.
Polygenic scores. What does that mean in this context?
Intelligence isn't controlled by just one single smart gene that you can turn on or off. It is influenced by thousands of tiny little genetic markers spread across your DNA.
Okay.
A polygenic score looks at all of them at once and gives a statistical probability. It essentially says this specific embryo has a high likelihood of high intelligence.
So you aren't actually changing the genes or editing DNA. You are just picking the smartest potential baby from the batch you already have.
Correct. You are just rolling the dice and looking at the results. But the math of that is currently limited. If a couple produces, say, 10 embryos naturally, the difference between the smartest one and the average one in that small batch might be pretty negligible.
Maybe just a couple of IQ points?
Right. It is not a radical evolutionary shift.
But the technology driving this is accelerating fast.
Enter IVG, which stands for in vitro gametogenesis. This is the real game changer here.
What is that?
This is the emerging technology that allows scientists to take a basic skin cell, just a totally normal cell scraped from your arm, turn it into a stem cell, and then turn that stem cell directly into an egg or a sperm.
Meaning you do not need to painfully harvest eggs anymore. You can just manufacture them in a lab.
You can theoretically manufacture thousands of them from a tiny skin scraping. And if you can make thousands of viable embryos, the math of selection changes completely.
Oh, wow.
If you can select the best embryo out of 100 or even 1,000 instead of just 10, you could theoretically select for extremely high intelligence. You could select for an IQ that is 3 or 4 standard deviations way above the normal human baseline.
That sounds incredibly dystopian. It sounds exactly like the plot of Gattaca.
It absolutely opens up an absolute ethical minefield. The semantic scholar source we looked at dives incredibly deep into this. First and foremost, there is the severe risk of global inequality.
They called it the prosthetic economy.
Yeah, exactly. That term originally comes from the idea after World War I that rich people could buy much better prosthetic limbs. But now it is being applied to human minds.
Oh, man.
Wealthy parents in the future wouldn't just be buying better tutors or better private schools for their kids. They would literally be buying better biological hardware.
It creates a cognitive divide that might be physically impossible to ever cross. The rich literally become a different biological species of intellect.
That is the fear. And there was an incredibly fascinating data point about global perspectives on this that the sources highlighted.
Right. I automatically assumed Western countries like the US or Europe would be all over this technology. We love optimization and being the best.
You would definitely think so. But the Siena Project survey showed the exact opposite trend. Western nations like Germany and the USA and France are actually the most skeptical and fearful about cognitive enhancement.
Really? Who is open to it then?
The countries that are most open to it are actually developing nations like Brazil and South Africa.
Why is that? That seems so counterintuitive to me.
The prevailing theory is that in developing nations, people see new technology as a vital bridge. It is a way to finally close the gap and leapfrog into a better future.
They see it as a potential tool for equality.
Exactly. Whereas in the West, where we are already quite comfortable economically, we might be much more concerned about preserving our status quo, or protecting the natural order, or we just fear that we will lose our essential humanity.
There is also a strictly philosophical problem here that really bit my brain when I was reading the source materials, the non-identity problem.
Oh, this is a heavy one. It is a classic philosophical paradox.
How does it work?
It asks a simple question. If you use gene editing or very strict embryo selection to create a better child, are you actually improving a person? Or are you just creating a completely different person entirely?
Right. Because if my parents had selected a different embryo instead of me just because I had a slightly better polygenic score, they did not prove me.
Yeah.
They just had someone else. I wouldn't exist to experience the upgrade.
Exactly. So you cannot logically say you were doing it for the child, because without the selection process, that specific child wouldn't even exist to benefit from it.
It challenges our whole fundamental notion of parental duty. Are you obligated to have the best possible child you can engineer, or just your natural child?
It is dizzying. We are just reporting what the ethical papers say, but neither of us are taking a side here. It is just a massive question we are going to have to face soon.
It really is dizzying. We have gone from a simple 19th century self-help myth about 10% usage all the way to a near future where we might literally be manufacturing genius in a lab just to compete in a global economy.
It is a totally wild ride, and I think it shows that our cultural obsession with brain power hasn't gone away at all. It has just shifted.
Shifted how?
It has shifted from hoping we can magically unlock it to realizing we might have to physically build it.
So let us try to bring it all back to the center and wrap this up. How do we synthesize all this heavy information for the listener? We have completely debunked the myth. We have looked at the hard biology. We have looked at the somewhat scary future of genetics. What is the real takeaway here?
I think we have to firmly accept the biological reality first and foremost.
Which is that we use 100%.
We use 100% of our brains. The human brain is an absolute masterpiece of biological efficiency. It is not a sad bucket of wasted potential waiting for a magic pill.
Right.
It is limited by energy, it is limited by attention, and it is limited by necessary biological trade-offs.
But that does not mean we are permanently capped.
Right.
That does not mean we cannot effectively get smarter or do more.
No, definitely not. And this brings us right to the extended mind theory.
Ah, yes, from the Avalon Library source.
Exactly. This is the philosophical idea from Andy Clark and David Chalmers, and they argue that we shouldn't just look inside the bone of the skull for human intelligence.
So looking at the phone in my pocket, the notebook on my desk, the laptop,
those are literal functional extensions of your mind. We constantly offload memory to them. We offload complex calculation to them.
Right. I don't need to memorize a map because I have GPS.
Exactly. We actively bypass our own biological bottlenecks, the retrieval problems and the energy limits. We bypass them by building and using external tools.
So the limitless potential isn't about finding a magic pill to activate the silent 90% of my brain tissue. It is actually about how I integrate with the outside world.
Precisely. We are already cyborgs in a very real way. We are already enhanced.
I love it.
The 10% myth survives because we desperately want to be magic. We want to be superheroes with laser eyes who can learn kung fu in 5 seconds. But the reality is we are tool builders.
Yeah.
And our profound capacity to build tools that physically extend our minds, like writing and mathematics and the internet, that is our real superpower.
I really love that perspective. It completely reframes the whole conversation for me. We do not need to feel guilty or anxious about wasting our brains. We are currently running a high-performance machine that is fully engaged all day long.
And because of that, we should take really good care of it. Feed it properly and rest it. Let it prune the connections it does not need while you sleep. Stop stressing about unlocking it and just start supporting it.
I want to leave the listener with one final provocative thought that came up during our research process. It is a bit of a twist on the original myth.
Let us hear it.
So we established firmly that we do not use 10% of our brain. We use all of it. But maybe, just maybe, we only use 10% of our imagination regarding how we actively connect with the world.
Oh, that is interesting. Go on.
We spend so much time absolutely obsessed with the raw hardware inside our own individual skulls. We think make it faster and make it remember more data. But as we saw with the savants and with the taxi drivers, pure processing power always has steep biological trade-offs. Maybe the real next massive step in human evolution isn't biological enhancement or genetic engineering at all.
You think it is integration?
Exactly. Integrating our biological intelligence with our external tools, sure, but also integrating much better with each other, creating a true distributed mind of society.
That is a very powerful thought. The overall network is always stronger than the single isolated node.
Exactly. The future isn't about lighting up more isolated neurons inside one person's head. It is about connecting those fully lit brains together in entirely new ways.
I could not agree more.
Well, that wraps up this deep dive into the 10% myth. We really hope you feel a little better about your fully utilized and energy-hungry and honestly miraculous brain today.
And thank you so much for lending us your attention for this. We know from the research that it is a very limited resource.
Indeed it is. Thanks for taking the shortcut to being well informed with us. We'll see you on the next deep dive.